people, what is up? How is everyone doing? I hope all of you guys are doing good as always and having a fantastic, fantabulous, super awesome day so far. And more importantly, your preparations for your term 2 examinations are going good. My name is Anoop and this is Vedantu. A very warm welcome to all of you guys out there. Again, this is going to be the Sprint X series, the world famous, the one that has set histories in the past. We're going to start it up again, people. This is the Sprint X series for term 2 examination. We'll start with electricity and then work our way to magnetic effects of electric current as well. So once again, a very warm welcome. But yes, before we start, get your pens and papers because I'm going to ask you some amazing questions and I want you guys to answer it in the chat box. All right. So with that, Josh people, I hope that you're Josh super duper high right now. With that said, let's get on to how I've divided the chapters. First, the topic itself. So electricity, today's session of Sprint X will be doing about current and potential difference, Ohm's law, resistance and factors affecting resistance. And then finally, we'll also do a couple of questions of series and parallel connection. In the next one of electricity, we'll be doing about heating. We'll be talking about heating effects of electric current, power, electrical power and energy and numericals based on that, and also commercial unit of energy as well. All right. Now, before we start, do not forget to hit the like button, subscribe to the channel if you want good luck in 2022. Yes, I am giving away good lucks right now. I'm the Christmas Santa of good lucks. All right. So anyways, apparently I had a motivational quote. I was supposed to put it and I just wrote it as motivational quote. That's me, people. Anyways, the motivational quote is be motivated all the time. Anyways, this is the schedule for the Sprint X for all the subjects. I'll just start with physics because why not? So physics, 23rd is the first session. So you'll be getting it this on 23rd of at 4 p.m. on 23rd. And on 25th, you'll have second session of electricity. On 28th, magnetic effects of session number 1. And on 30th, magnetic effects session number 2. And again, guys, do not forget to subscribe because there are some amazing stuff, amazing set of questions that is coming your way. So I'm pretty sure none of you guys would like to miss out on that. For biology, taken up by Maria ma'am, we would be having how do organisms reproduce on 24th and 26th, and then heredity and evolution, that is on 29th, and on 30th we have our environment. Following, we have chemistry, that is taken up by Shilpi ma'am. We have carbon and its compounds 1 and 2 on 23rd and 25th, 26th periodic classifications of elements, and on 28th periodic classifications session number 2. Then for Sprint X, for English, taken up by Shweta ma'am, we have glimpses of India plus tenses, Madam Rides the Bus plus models. Yo, what a good name. The sermon at Benares, all right, like Banaras. Then we have proposal and then Amanda. All right, followed by animals, the tale of Custer the dragon, the making of scientists plus letter of inquiry, then the necklace, analytical paragraph, the hack driver, Boli, and factual passage. My God, people, there's a lot of English sessions coming up, followed by mathematics taken up by Gopal sir. Again, I'm pretty sure there's a ton of these as well. Quadratic equations, arithmetic progressions, circles, construction, some applications of trigonometry, surface area and volume, and statistics. So these are all the sessions planned on math. And last but not least, we have our own Ananya OP sir. We have nationalism in India, manufacturing and industries, lifelines of national economy, political parties and outcomes of democracy. Alright, so these are all the topics. No, not done yet. Money and credit, globalization and the Indian economy. Map 1, that is a history, and map 2, that is geography. Alright, so you're gonna learn about money heist and whatnot in Ananya's session. Alright, so that's it, people. Let's get out of the questions now because I've talked a lot. So let's start with the 2 markers and then we'll work our way to 3 markers and then 5 markers, right? So the 2 marker questions would be straightforward. A couple of numericals, but simple jujube, EGPG numericals is what you have. So I'll start with the first question, people. On your screens, again, I want you to do it with me. It's not just me. See, the Sprint X works like this for all those who are new. Generally, if you have a 2-mark question, you would take about 2 to 3 minutes to finish it off in your exams. In Sprint, we don't got 2 minutes, people. We'll do it in less than 1 minute. We'll try to finish it off. All right. So the question is, people, 3 into 10 to the power of 11 electrons are flowing through the filament of a bulb for 2 minutes. Find the current flowing through the circuit where the charge of one electron is 1.6 into 10 to the power of minus 19 a coulomb? How do you do this? Super easy question. Now again, if you need more time, you can always pause the video and then do it and put down in the chat box. But I'm just going to start with anyways because we have to cover a lot of questions. So let's be very prompt and let's try to do it as quickly as possible because it's sprint, right? It's not a marathon. It's not a slight jog. It's not a jog session. It's not like a brisk walk session. It's sprintex. So we sprint like a cheetah. So yeah, the first thing you need to understand is people, the number of electrons given is 3 into 10 to the power of 11 electrons. So there are number of electrons is 3 into 10 to the power of minus 11. The time given is 2 minutes. So convert that to seconds. So into 60, that's basically 120 seconds. Super awesome. The charge of an electron Q, the charge of an electron, sorry, E, right? E is equal to 1.6 into 10 to the power of minus 19 coulomb. You have to find out what is the current flowing through it. So remember people, current is nothing but rate of flow of charge. Now, Q, that is nothing but charge is nothing but N into E. That is nothing but the number of electrons into charge of an electron. So you can also write it as I is equal to NE divided by T. Just substitute the values over here. 3 into 10 to the power of 11 into 1.6 into 10 to the power of minus 19 whole divided by 120. How much is that? 3 into 1.6 into 10 to the power of minus 19 plus 11 whole divided by 120. When you solve for this, you will get it as 4.8 into 10 to the power of 8 divided by 120. When you solve for this, you will get it as 4 into 10 to the power of 10. What? 10 what? 10 what, people? 10 amperes. Yes. 4 into 10 to the power of 10 amperes. So that's the answer. All right. So I guess I didn't take 1 minute, but I don't know. I'm not timing myself, but I'm hoping that it took less than 1 minute. But yes, again, to explain the same concept, guys, I could have done it directly, but then I have to explain it to you people. So it will take a little longer for me, but I'm hoping that you guys are able to do it in 1 minute because again, you don't have to explain it to anyone. You just have to prove it to yourself. And that's pretty much it. So I would take a little extra time so that I can, show you the steps, each and every step to solve it. So don't judge me for it. All right. I know. The comment section, I know, but yes, so please make sure that you guys take your own time, but yes, try to do it in 1 minute or less than that because this really isn't that big of a question, not that hard of a question. Moving on to the second question, again, it's a 2-mark question. Exam time 2 minutes, but sprint time 1 minute. The question is 3 equal resistances are connected in series and then in parallel. What will be their ratio of resistance? Super easy question, guys. Again, take your time. If you need more time, pause the video, give yourself exactly 1 minute and try to do it. But me, people, I'm going to do it myself now. Look at this. See, RS, which is nothing but the equivalent resistance when they are connected in series. Since there are 3 resistors, I'm going to take the value of each resistor R, small r. So it's R plus R, which makes it 3R. And 1 by RP, when they're connected in parallel, it's going to be 1 by R plus 1 by R plus 1 by R, which is going to be 3 by R. So RP is equal to R by 3. Now you have to find out the ratio. So what is the ratio? RS by RP, which is equal to what? 3R divided by 3 by R. R will go to the, sorry, R by 3, right? My bad. Sorry, guys. It's R by 3. It's R by 3. My bad. R by 3. When you put that over here, it's R by 3. When you take that to the numerator, you'll get as 9R by R gets cancelled. So you'll get the ratio as 9:1. So that's the answer, guys. The ratio of resistance between a series connection and parallel connection, if they have the same resistance, then the ratio in this case is going to be 9:1. Voila, that's it. Moving on to the next question, people. I hope you got it right. Whoever got it right now, hats off to you people, because I know you guys are putting in the effort and I can see it right now. Third question, again, 2-mark question, 2 minutes time. Let's try to do it in 1 minute. On what factors does resistance depend on? It won't even take you 15 seconds. This question is so jujube that it'll not even take you 15 seconds. It's like so jujube. Come on. How do you do this? Very simple question again, people. What are the factors that resistance depends on? I don't think you need 1 minute for this. I'm just going to write it down straightforward. Resistance is directly proportional to the length of the conductor. So more the length, more is the resistance. Resistance is inversely proportional to the area of cross section. More is the area of cross section, less is going to be the resistance. The third factor that resistance depends on is the resistivity or the property of the material itself. It also depends on the property of the material. Last but not the least, don't just stop there, people, because it's Vedantu. We don't just stop there. The last and the final factor that it depends on is temperature, because temperature is also a deciding factor. More the temperature, greater the resistance, and hence temperature also is taken into consideration. Although we don't write it in the formula, doesn't make it any less true. All right, so these are all the different factors that resistance depends on. Moving on to the next question, yet another one, super easy numerical. 2 minutes time is what you have in your exams, but sprint 1 minute, 2 marks, super duper easy question. Let's try to do it, people. Do it with me. Full Josh, here we go. The charge possessed by an electron, is 1.6 into 10 to the power of minus 19 coulomb. So charge of an electron, we'll take it as E, is 1.6 into 10 to the power of minus 19 coulomb. Awesome. Find the number of electrons that will flow per second to constitute to a charge or to a current of 1 ampere. If the current given is 1 ampere, how much charge is flowing through that particular point in 1 second time per second, right? So time taken is also given as 1 second. So how do you do this again? It's the same formula, people. I is equal to Q by T. We know that Q is equal to N into E. Substitute the value here. So I is equal to NE divided by 2. Substitute the values. So I is given as 1. Number of electrons is what you're supposed to find out. The charge of an electron is basically 1.6 into 10 to the power of minus 19 coulomb. And this is nothing but 1. So how do you find out N? N is equal to 1.6 into 10 to the power of minus 19. Sorry, 1 divided by 1.6 into 10 to the power of minus 19. Which, when you simplify, you will get it as 6.25 into 10 to the power of 18 electrons would be the answer. So N would be equal to, yes, 6.25 into 10 to the power of 18 electrons would be the answer. Super easy question, isn't it? I know. That's why you have to subscribe to the channel because we bring in good luck to you people, right? Moving on to the next one. Now that last question marked the end of section A, which was basically all of 2 marks each. Now we are going to move on to the 3 markers. Now again, 3 markers, it's going to be a little bit more difficult. We're going to increase the difficulty level just ever so slightly, but don't worry, I've got you covered. I'm there with you guys. Don't worry. Let's take one step at a time. So here's another one, guys. Define electric resistance of a conductor. A wire of length L and resistance R is stretched so that its length is doubled and the area of cross section is halved. How will its resistance change and its resistivity change? It's a 3-mark question, which means each of the sub questions carries 1 mark each. 3 minutes in your examination. We will try to do it in less than 2 minutes. Trust me, guys, we will try to do it in less than 1 minute. Let's go. So yes, put it on in the chat box in the meantime. Here is the answer, guys. So 5th question for section number 8. Define electric resistance of a conductor. Resistance is nothing but the obstruction offered to the flow of current. Obstruction, the spelling of obstruction is, yes, you get it, people. It's not an English session, so don't judge me for it. I'm so used to autocorrects that these days I am expecting it to be automatically corrected. Yes. Resistance is the obstruction or the opposition to the flow of current. You can call it as obstruction or you can call it as opposition to the flow of current. To the flow of current. To the flow of current is what is called as resistance. Now, if you have a wire, let's say, right, to answer the second part of the question, you're just stretching the length. So the new length is twice the length of the original length, and the new area is half the area of the original area. What will happen to the resistance? Because we know that resistance is equal to rho into L by A. The new resistance R dash is equal to 2L divided by 1 by 2 into A. This 2 will go to the numerator, so you'll get it as R dash is equal to 4 into rho into L by A, which means that the resistance is going to increase 4 times the original one, because rho into L by A is nothing but R. So you'll get as R dash is equal to 4 into R, which means the resistance is increasing 4 times more. But what about the resistivity? The resistivity will remain exactly the same. Why? Because resistivity does not depend on the length or the area of cross section. All in all, the resistivity is a factor that it's basically a property of the material which depends only on the material itself. That is the property of the material. It does not depend on the length. It doesn't matter whether you cut it in half, whether you chop it into 10 pieces and you make a, barbecue out of it. It really doesn't matter. Resistivity is still going to remain the same. Why? Because it is a property of the material. Alright, so that would be the answer for this question. Super easy, isn't it? Less than 2 minutes. I'm pretty sure I got it down less than 2 minutes. Alright, 6th question, people. Again, a 3 marker for 3 minutes, but yes, We'll try to do it in less than 2. A piece of wire of resistance is drawn out so that its length is increased to twice its original length. Calculate the length of the wire, calculate the resistance of the wire in the new situation. Okay, so here is the thing, guys. Initially, you have your wire. You're pulling this wire from both the sides and making the length of it twice the length of the original one. Alright, so the new length, I'll take it as L dash is equal to 2 times the original length. Now, they've not mentioned about the volume per se. Right, so we're going to assume that the volume is remaining exactly the same. So volume is same. We know that volume is equal to length into area or area into length, right? A into L or L into A. Area into length is nothing but volume. So the new volume, which is will take as V dash, is equal to the old volume. Obviously, the volume would remain the same, even though the length is increasing or the area is increasing. It really doesn't matter because the volume has to remain exactly the same. So the new area into the new length is equal to the old area into the old length. Now they're saying that the new length is twice the original length. So A dash is equal to 2 into L, which is equal to A into L. LL gets cancelled. So what is that? A dash is equal to A by 2. So what is happening is that when you increase the length of the wire 2 times, the area of the wire decreases to half of it. That's what it means, because the volume is remaining exactly the same. The volume is not changing. So that's what you get. Now that you've understood this, what would be the resistance of the new wire? Let's put that in the equation. R dash is equal to rho into L by A, which is equal to rho into 2 into L divided by the new area is A by 2 again. So this goes to the numerator. So you'll get as what? 4 into rho into A by L, which means that the resistance again is going to increase 4 times the original resistance. So that will be the answer. And here, since they've not given the resistance, I don't know, for some reason they've taken the resistance as 20. But yeah, they have not given us the resistance. But if in case, that's just a example, if in case the resistance is 20, the original resistance was 20, the new resistance would be 4 times of that, which would be nothing but 80 ohms. Tada, people, tada! And yes, guys, before I go to the next question, I want to know, out of how many questions? Out of 6 questions, how many of you guys have gotten all the questions right? Put it down in the chat box right now. How many of you guys got all 6 questions right and you've been doing really well so far? Don't jinx it though, but yes, so far so good. Moving on to the 7th question then, people. Put it in the chat box though. I want to see how many of you guys got it right. Alright, 7th question. In the given figure, what is the ratio of ammeter reading when J is connected to A and when J is connected to B? 3-mark question, 3 minutes. We will try to do it in less than 2. Unfortunately, I don't have any space, so I'm just going to write it over here itself. So initially, guys, you can see this is connected over here. Then you're connecting this over here. J, you're connecting A to B. Let's start with A first. So if it's connected to A, there are 2 batteries now. So what will be the total voltage? Total voltage would be equal to 1 plus 2, which is equal to 3 volts. Simple. Resistance is going to remain the same, 5 volt itself. That really doesn't matter because there's only one resistor there. So what is the current then? V by R, which is equal to what? 3 by 5, which when you calculate, you will get something around 0.6 amperes, something like that. 0.6 amperes would be the answer for the first part of the question. So that's done. So this, if you do, you would get 1.5 mark. Now to answer the second part of the question, now the new voltage, since you connected at B, all of the batteries are now involved. All of the batteries are now connected. So what will be the total voltage then? It will be 4 plus 3 plus 2 plus 1, which is nothing but what? 4, 6, 9, 10 amperes. 10 volt would be the voltage. Current is resistance is exactly the same, 5 ohms itself. So what will be the, sorry, I wrote it as volts over here, no, my bad, sorry. So what will be the current? Current is equal to what? V by R again. So it's something but 10 by 5, which is equal to 2 what? 2 amperes. So that will be the answer, guys. Super easy question. 0.6 amperes and 2 amperes would be the answer. That's pretty much it. Moving on to the 8th question now. 8 questions down, people. First of all, high five to all of you guys for staying until now. The courage, the dedication, the spirit of examination is in you. May God bless you all. Yes. Alright, let's go on to the next question, guys. A battery of 9 volt is connected in series with a resistance of 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms respectively. How much current would flow through the resistor? Through the 12 resistors. What? How much current would flow through the 12 resistors? Okay, the 12 ohm resistor. Sorry guys, sorry. It's 12 ohm. I'm like, where there are 5 ohm, 5 resistors in total. How are there 12 resistors all of a sudden? It's 12 ohm. Okay, you have to find out what is the current flowing through 12 ohm resistor. Okay, first thing first, write on the given data. Voltage is given as 9 volts, ton. The total resistance R equivalent is equal to what? They're all connected in series. So you just have to add it up. 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. How much is that? That is basically 13.4 ohms, right? Because this is nothing but 0.5 plus 0.5 is 1 plus 0.4 is 1.4 plus 12 is 13.4 ohms is what you're gonna get. Super awesome. Now to find out the current is equal to voltage by resistance, which is equal to what? 9 by 13.4, which when you divide you will get something like 0.6, 0.67, 0.66667, something like that is what you're gonna get. Okay, so this is the current flowing through the circuit right now. That is through all of the resistors. So what will be the current flowing through the 12 ohm resistor then? Because they're connected in series, current would be the same. So in the 12 ohm resistor also, the current flowing through it would be 0.67 ampere itself, because they're all connected in series. Getting it? समझ रहे हो भैया? भैया जी समझ रहे हो? That's what. So the answer is going to be 0.67 amperes. Ta-da, people, ta-da! Moving on to the 9th question, guys. Here is the 9th question. Again, a 3 marker, 3 minutes time, but we'll try to do it in 2. Show how would you connect 3 resistors, each of resistance 6 ohms, so that the combination of resistance has 9 ohm in one connection and 4 ohms in one connection. Now, this is an awesome question, guys. This is truly a really awesome question. Each of these questions carries about 1.5 marks each, 1.5 over there, 1.5 over here also. Super duper amazing question. Pay attention, you'll get it right. Now this is actually a lot of you can say hidden trial method, because you have to, you know for a fact that, guys, when you have 3 resistors, if you connect them in series, for sure your resistance will be greater than what is expected. So it cannot be, you won't be getting 9 ohms, neither will you be getting 4 ohms. Now if you connect them parallelly, there is a chance that you might be getting 4 ohms, but let's try to do it first. Let's try to connect them all in parallel and see if we can get the right answer. So we are connecting all the 3 in parallel. Since they're of the same resistance, R equivalent is equal to 6 by 2, which is nothing but 3 ohms, right? Because it's nothing but R, when you have n number of resistance, R equivalent is equal to R by n. So just substitute the value over there, you'll get the answer, which is nothing but what? So sorry, this is 3 resistors. No, my bad, sorry. 3 resistors, sorry, it's going to be 2 ohms because there are 3 resistors of each of 6 ohms. So it's 6 by 3, which is nothing but 2 ohms. That is the equivalent resistance. So if you connect them in series and if you connect them in parallel, you will not get the desired result. So let's do one thing. Let's first connect 2 resistors in series and then we'll connect one parallel. All right. So 6 ohms and 6 ohms. What will be the equivalent resistance over here? So R, let's say this is R1, this is R2 and R3. Again, this is a hit and trial method, people. So be sure to try out all the possibilities. So 6 plus 6, nothing but 12. And so 1 by R equivalent is equal to 1 by 12 plus 1 by 6 into 2 into 2. That's basically 3 by 12. So R equivalent is equal to 12 by 3. Basically 4 is a 12, so 4 amperes. So yes, 4 ohms would be the answer. So you can get the 4 ohm connection, 4 ohms. If you want to get 4 ohms, all you have to do is connect 2 of them in series and one parallel to both of them. So you'd get that. This is one combination, and you'll be getting the 4 ohm resistance. Another combination that you want or you can use over here is basically to connect 2 in parallel, 1 in series, right? We'll connect 2 in parallel now, 2 parallel and 1 in series, like this. All right, sorry for that, like this. Let's try to do this also. 6 ohms, 6 ohms and 6 ohms. So this is 1 by 6 plus 1 by 6, which is nothing but 2 by 6. So R1 by R12 is equal to 6 by 2. That is R equivalent, R12 is equal to 6 by 2, which is equal to 3 ohms, right? So 3 ohms is the resistance. So 3 plus 6 is how much? Because these two are in series. Once you solve that, those two will be in series. So R12 plus R3 is equal to 3 plus 6, which is equal to 9 ohms. So the answer is going to be this and this. So you have to, again, it's a lot of hit and trial method. So it's not that there's a direct answer as such, but yeah, it's a lot of finding out the right combinations, and you'll get it. But it's a little time consuming, I understand. It's a little time consuming, but it's worth it if you get it right, because you end up getting 3 marks for such an easy question, right? Moving on to the 10th question, guys. Define the term volt. Sorry, my throat. All right. Define the term volt. State the relationship between work, charge, and potential difference for an electric circuit. Calculate the potential difference between two terminals of a battery of 100 joules of work is required to transfer 20 coulombs of charge from one terminal of a battery to another. Such an easy question. 3 minutes, though, you don't even need. This stick to direct answer. So how do you define 1 volt? 1 volt is nothing. Volt is nothing but the SI unit of potential difference. So what is 1 volt? You can define 1 volt. 1 volt is nothing but the potential difference is said to be 1 volt when 1 joule of work is done to move a charge of 1 coulomb. That's it. When the work done on the work done is said to be 1 joule on a charge of 1 coulomb, that is when the potential difference is said to be 1, or the voltage is said to be 1 volt. Now, what is the relationship between work done, work, charge, and potential difference? Very simple, guys. The formula: potential difference is equal to work done by charge. This is the relationship. Potential difference is equal to work done by charge. Calculate the potential difference of two terminals if the work done is said to be 100 joules and the charge is said to be 20 coulomb. What is the work done? So what is the potential difference? So it'll be 100 divided by 20, 0 gets cancelled, 2 5s are 10. So the potential difference is going to be 5 volt. Simple as that. So that will be the answer. Simple, 3 marks, done and dusted. All right, guys, now before I go to the next question, which will be basically the 5 marker, I have some amazing news for all the dreamers out there, all the people who always wanted to become an engineer or a doctor, and you've worked from day one in order to make that happen. I'm going to tell you something which is going to change your life forever, just like how we have helped change more than 1,400 people's life to make them, to make them an engineer, and about 1,200 people who have cleared their NEET and become doctors of tomorrow. So if you guys want to be an engineer or a doctor and you're looking for a solid course which is going to help you do just that from one of the most premier institution which has provided such amazing, fabulous results in the past, the link for that is in the description, people. Once you click on that link, you are entering into a world of amazing content where you're getting the best of the best teachers for an affordable price. 2 years course of JEE, the Drishti batch of 12th and 11th, where you're getting your JEE preparation and your class 10th revision as well. It's included, class 10th revision, because you're going to give your exam another 2 months. Your class 10 revision along with 2-year course, all of it for a price of 53,999 rupees. That's basically 54,000 rupees. Now you might think that's a lot of money, but for the next 24 months, people, I am not talking about 1 year, I'm talking about the next 2 years, including your 12th, 10th revision, all of it for such a nominal price, which is basically about 3,000 a month. A JEE course where you're going to get into one of the most premier institutes in the world, one of the toughest exams in the world. You would be getting the best of everything, the doubt solving that you love about Vedantu, the amazing platform, the replays with quizzes, and tons of fun, and more importantly, knowledge. That's what you're getting for this, right? Now, if you're skeptical and you're like, sir, 54,000 is a huge commitment, and I understand that. If you feel like, sir, that's a huge deal for me, then I would suggest you to go for the 15-day trial program. The 15-day trial program is going to cost you 1,350 rupees in total. And this is after my coupon code AME Pro. So once you apply my coupon code, it will drop down to 1,349 rupees. And the best part about this is, people, this 15-day trial will actually increase to 30 days. So you're getting 1 full month of one of the best online classes for just 1,350 rupees, which is very, very affordable. And you would be getting teachers like Arvind Kalia, who is from IIT Delhi, Ankit Gupta sir, who's from IIT Roorkee, from Shimon sir, who's a BTech, and Drivendra sir from IIT Roorkee again. So you'll be getting the best of the best teachers and nothing but the best. All right. So yes, what are you waiting for? I know that your exams are coming up, but at the same time, you should also think about your future. Think about starting your preparations for your 12th standard, 11th standard from now. And this would be one of the best chances to start, because your schools will be starting a little later, which means you have time for your preparations. And at the same time, you'll also be one step ahead of your school as well. All right, guys, with that said, let's now get into the Rattamar questions. The Rattamar and Jor Se Lik questions, which is basically the 5-mark question, where you write stories of your grandfather, grandmother, about how they fought in the Indian War and they helped India to get freedom. I know. That's what you do in a 5-mark question. Don't. I know. Now, just look at yourself in the mirror. I know it's you. I'm talking to you. Alright, now let's talk about the 5-mark questions. So yes, people, in a 5-mark question, so in your exams, you should roughly take about 4 to 5 minutes, definitely not more than that. But yes, we'll try to do it in less than 3. 5-mark question. Let's go, people. Here's the first one. State Ohm's law. Draw a labeled circuit diagram to verify this law in the laboratory. If you draw a graph between the potential difference and current flowing through a metallic conductor, what kind of curve will you get? Explain how will you use this graph to determine the resistance of a conductor. Yes. In one breath. Yes. Okay, let's try to do this way. So let's do one step at a time. What is Ohm's law? Ohm's law states that the current, when the potential difference is kept, when the potential difference is kept constant, you can see that as the potential difference increases, the current, basically you can say that the potential difference applied across a conductor is directly proportional to the amount of current flowing through it. All right. I don't know why it took me so long to put in words. Right. The amount of current flowing through a conductor, or you can say that the amount of current flowing through a conductor is directly proportional to the potential difference applied at the two ends. So that is basically what is Ohm's law. Draw a labeled circuit diagram to verify this law. So you can verify it in a very simple manner, guys. All you have to do is connect an ammeter, connect a battery, and then let's say you connect a resistance or a bulb, whatever you want, and then a voltmeter which is parallel to it. So this is one of the most simplest circuits that you can use to actually verify the existence of Ohm's law. So when you increase from 1 cell to 2 cells or to 3 cells, the amount of voltage increases, and as the voltage increases, the current would also increase. So that's a simple circuit to represent the same. Now, to answer the third part of the question, which again is a very important one, if you were to draw a potential versus current graph, how would that graph look? Very simple, guys. If your current is in your x-axis and your voltage is in your y-axis, then the graph would basically be nothing but a straight line. It's going to be a straight line. Why? Because as the potential difference increases, the current also increases. Now, how would you get the resistance from this? Very simple. All you have to do is find out the slope. So the slope of the graph, slope of VI graph, will give you the resistance. Will get the resistance. So that's the answer, guys. 5-mark question. So easy. So very easy this question is. But yes, it's all about dividing and conquering. So step by step, solve it and you're good to go. So yes, people, put it on the chat box. Out of 11 questions so far, how many did you get it right? How many answers did you get the right answer for? Let me know in the comment section. Let me know in the chat box. And all the comments, I'll be putting it up in the next session, in the start of my next session. So be sure to put it down in the comment section. Tell me how proud do you feel since you've completed all these questions. Super proud, no? I'm also proud of you guys. High pie. Congrats. Now, as a homework question, because we're not done yet, I'll give you a small homework question. Put it on in the comment section as well. Tell me how much did you score? How many questions did you get right? And on top of that, tell me the answer for the homework as well in the comment section. The question is, what is an electric circuit? Distinguish between an open circuit and a closed circuit. Simple. Put on the comment section. That's it from my side, people. I'll catch you guys in the next session on 25th of March. Until then, this is Anoop signing off for the day. Have a fantastic, fantabulous day, people. I'll catch you guys soon. Peace out. Stay safe and be good. Good luck. I'll see you soon. Bye.